Alright, so in this video I want to look at how to solve trig equations. Graphically, it's very similar to solving any equation with a graph, but trig equations are a little bit different in that they are periodic, right? So they repeat over a given interval. So when we're solving equations graphically in here, at least for these problems in this section, we're only going to be looking for solutions between 0 and 2 pi. That simplifies things a little bit because there's an infinite number of solutions to these equations. When we get to the second section where we talk about solving them algebraically and some of the simpler problems, we will look at how to actually identify and explain the infinite number of solutions that show up. But for now, we're just going to look between 0 and 2 pi. So if we take that first example you have there, which is sine of x equals 0.3, and we want to solve that, there's two ways that we can do this. We can graph the left and graph the right, or we can move everything to one side and set it equal to 0. I'm going to show you just graphing the left and the right here because the next two examples will set it equal to 0. Okay, so if I am trying to solve sine of x equals 0.3, I'm going to graph the left and I'll graph the right, and then the intercepts, or the intersections here, are the solutions. Okay, so here we have a solution at 0.305, a solution at 2.837, and this solution is outside of 2 pi. You can see 2 pi is here, it's outside of it. So there's only two solutions that fit on this interval, x equals 0.305 and 2.837. Let's go on to the second example here. Alright, so example 2, what we're trying to do is solve 2 sine squared x minus cosine x minus 1. And that's already set equal to 0. So what we're going to do is graph that, and then we're going to find the x-intercept. So that's what we're looking for when we solve by graphing. Now this is a pretty weird function, but remember we're looking for x-intercepts. So let's highlight those, and on your calculator you're going to have to go, you're going to have to use the zero finder to do this, right? So second calc 0, and then pick a point to the left, a point to the right, and then it will find the 0 for you. So we've got them here at pi over 3, pi, and 5 pi over 3. Now, I'm probably not expecting you to identify pi over 3 when it spits back a decimal, but pi you should be able to figure out. Even pi over 2 and 2 pi and 3 pi, intervals of pi, you should be able to identify. But things like pi over 3, pi over 8, pi over 6, I'm not going to expect you to know those decimals and what they convert to, and how they convert back to an exact value. Okay, so the last one here is tan x equals 2 times sine of 3x. So let's look at that example. Alright, so tan x equals, so this is the equation we want to solve. Let's look at tan. So first of all, if we wanted to solve graphing by both sides, this is what happens. I'll graph tan, and I'll graph 2 sine of 3x. Now this looks like a nightmare, right? I mean, even if you look between just 0 and 2 pi over here, remember you're looking for the intersection, so you've got an intersection here, you've got an intersection down here, there's an intersection over here. It's actually not terrible, right? But it's going to look worse on your graph in your graphing calculator than it does here. In addition, we can make equations that are worse than this, right? That the curves are even crazier than this. So the technique here is if you've got something that's complex like this, the best method is to move everything to one side and find the x-intercepts. Okay, so let's do that. Tan x minus 2 sine 3x is what it would look like if I move this that expression to the left. And so this is what the graph looks like. Now it's still a weird graph, right? But it's a little bit easier to see the intercepts. So, well, excuse me, it may not be that much easier in this example, but at least we know we're only looking for intercepts. So there's one here, there's one here, there's one here, there's one here, and there's one here. So there's actually 5 solutions. So x equals 0, x equals 0.847, x equals pi, x equals 2 pi, and x equals 5.436 are the solutions. And that's how you're going to solve them graphically. Like I said, we're only looking between 0 and 2 pi, and that's it.